$60 billion. That's the value of the global recycled aluminum market. This enormous figure not only represents a highly profitable industry, but also demonstrates a sustainable development trend. But how exactly do these old aluminum cans transform into gleaming, like-new sheets of aluminum? Few people know that each piece of aluminum must undergo a series of rigorous processing steps before it can begin a new life cycle. Watch the video below to discover this complete, closed-loop process, and understand why aluminum recycling is the solution to both economic and environmental problems today. Few people know that aluminum is one of the very few materials that can be recycled almost indefinitely while maintaining its quality. This is why aluminum recycling is considered one of the most effective solutions for building a circular economy. Furthermore, the recycling process saves up to 95% of energy, significantly reducing carbon emissions and the need for natural resource extraction. However, a paradox is occurring. Despite these outstanding benefits, the recycling rate of aluminum cans in the US has been declining in recent years. This means that billions of aluminum cans each year are not returning to the recycling process, resulting in a large amount of valuable raw materials and potentially saved energy being wasted. What do you think are the reasons why the recycling rate of aluminum cans in the US is still declining, even though it is one of the most valuable recycled materials in the world? Share your thoughts in the comments. The aluminum recycling process begins with collecting aluminum products that have completed their life cycle. The raw materials come not only from used beverage cans, but also from window frames, building materials, electrical wires, and even decommissioned airplanes and trains. Each year, tens of millions of tons of aluminum scrap are recovered from these sources, preparing them for a new life cycle. Interestingly, aluminum is one of the most economically valuable types of scrap. Therefore, instead of being discarded, most used aluminum is collected and returned to the production chain. In many U.S. states, people can even receive up to $1 for each can they bring to collection points through the container deposit program. This seemingly simple mechanism has contributed to the recovery of billions of aluminum cans annually. After being collected from various sources, aluminum scrap is transported to collection points or recovery centers to prepare for further processing. Here, aluminum from beverage cans, automotive parts, construction materials, or household appliances is gathered at one location instead of being transported directly to a factory. Because aluminum has a relatively low density, transporting it in bulk would take up a lot of space. Therefore, at collection centers, scrap is usually piled into large lots, weighing around 1,000 pounds before being compressed into bales. Not all aluminum is the same, so the next step is to sort it into material groups. First, workers remove large impurities such as plastic, wood, rubber, or fabric. Next, the material passes through a system of high-powered magnets to separate ferrous metals like steel. Interestingly, aluminum is not attracted by the magnets, so it continues to move on the conveyor belt. To separate aluminum from the remaining materials, many modern factories use eddy current separators. This device generates a force that pushes aluminum pieces off the conveyor belt, while plastics, glass, and other materials continue to fall along their original trajectory. To make the recycling process more efficient, aluminum scrap is fed into high-capacity industrial shredders. Inside the machine are numerous shafts fitted with wear-resistant steel blades, rotating with very high torque to shred and cut bulky aluminum blocks into small pieces. In just seconds, Soda cans, door frames, or car parts can be shredded into pieces as small as 1 to 4 inches, depending on the requirements of the production line. A modern shredder can process about 20 tons of aluminum scrap per hour, meeting the needs of large-scale recycling plants. In addition, during the shredding process, many systems also integrate vibrating screens and dust extraction equipment to remove fine particles and remaining impurities. Before being melted, the aluminum pieces pass through a decoating furnace to remove any remaining paint, ink, and coatings, minimizing impurities and fumes generated during the smelting process. Then, the aluminum is fed into industrial melting furnaces, where the temperature is raised to approximately 1,400 degrees Fahrenheit. At this temperature, the solid aluminum pieces gradually transform into a bright silver liquid metal in a short period of time. Depending on the scale of production, a modern furnace can hold from 50 to over 100 tons of molten aluminum in a single batch. To ensure even temperature distribution, the liquid metal is continuously stirred using specialized equipment, minimizing localized overheating and ensuring a uniform alloy composition. When aluminum melts in a furnace, a layer of slag called dross gradually appears on the metal's surface. This slag is formed from oxidized aluminum, along with dirt, leftover paint residue, and other impurities. To remove it, specialized slag scraping equipment or robotic arms gently skim off the dross floating on the surface and remove it. This process is repeated several times throughout the melting process to keep the molten aluminum clean and stable. Interestingly, dross is not entirely waste. It still contains a certain amount of aluminum, which can range from 80% depending on the type of furnace and operating conditions. Once the required purity is achieved, molten aluminum is poured into molds to form standard-shaped aluminum ingots. To ensure a continuous casting process, the temperature of the molten aluminum is consistently maintained at a high level, helping the metal maintain a stable flow throughout the pouring process. In many modern factories, this process utilizes direct chill casting technology. Molten aluminum is continuously poured into open-bottom molds. The aluminum in contact with the mold solidifies first, while the core continues to be filled with molten aluminum until the entire metal solidifies completely. Each finished slab can be approximately 20 inches thick, 6 feet wide, over 30 feet long, and weigh up to 20 tons. After the aluminum begins to solidify in the mold, the system continuously sprays water onto the outer surface to accelerate the cooling process. Once completely cooled and solidified, the aluminum block is separated from the mold. First, a hydraulic system slowly lowers the mold, while mechanical clamps firmly hold the aluminum ingot and lift it out of the mold. The entire process is slow and steady to avoid cracking or deforming the metal block, while it still retains a significant amount of heat inside. Immediately afterward, the aluminum ingot is placed on a conveyor belt or roller system to continue cooling in the air. The newly selected billets are then sent to the rolling line, where they are pressed into thin sheets of aluminum. First, the billets are heated to make the metal more ductile. Then they pass through a hot rolling system, consisting of many pairs of giant steel rollers. Each time they pass through a pair of rollers, the thickness of the billet decreases, while the length increases significantly. This process is repeated many times until the billet reaches the required thickness. Once sufficiently thin, the aluminum is coiled and transferred to the cold rolling stage. Depending on the intended use, the aluminum can be further rolled down to as little as 0.01 inch. One of the most common applications of recycled aluminum is in beverage cans. This process begins with massive rolls of aluminum, which are fed into a stamping machine to be cut into round metal discs. Next, each billet undergoes a deep drawing process, where strong pressure shapes it into a shallow aluminum cup with a flat bottom. From there, the cup continues through several drawing and thinning stages, gradually increasing the height while reducing the wall thickness to a standard thickness. Once the can body is complete, the rim is curved in preparation for the subsequent lid attachment. Finally, the can bodies are printed with designs using a high-speed printing system before being stacked in batches and shipped to the filling plants. Once the production and filling process is complete, aluminum cans quickly become ubiquitous in every aspect of life. They sit on supermarket shelves, in convenience store refrigerators, on family dinner tables, and accompany picnics and large gatherings. Every day, hundreds of millions of cans are opened worldwide, becoming a familiar part of modern life and satisfying the refreshment needs of billions of people. From a used can to brand new aluminum products, each step in the recycling process demonstrates the immense value of modern technology and the circular economy. Behind a seemingly ordinary material lies an entire industry contributing to energy savings, reduced resource exploitation, and environmental protection. If you found this video helpful, don't forget to like it, leave a comment sharing what impressed you most, and subscribe to the channel to not miss other fascinating explorations of production and recycling processes. See you in the next video.